buoyancy goes hand in hand with displacement, and therefore we have already discussed a little bit about buoyancy in the displacement and draft introduction video. In this section, we will add to that. So when we're looking at a ship, the buoyant forces, just like the gravity forces, are acting all over the parts of the ship. We can combine all these forces into one point, called the center of buoyancy, where all the buoyant forces act at that one point. In a typical ship, you'd expect the center of buoyancy to be slightly aft because that's where the fullest part of the hull is located and where the center of buoyancy can counter the center of gravity. I can change my point of center of buoyancy by changing the shape of my underwater hull. Center of buoyancy is constantly changing because the ship is moving about on the water. The center of buoyancy is located by longitudinal and vertical distances from the reference point. So my vertical distance in this picture would be from my baseline to my center of buoyancy, and that is my vertical center of buoyancy. The transverse center of buoyancy does not exist because the boat's hull is symmetric and the boat is upright. Now, of course, if the boat is moving about in the water and say the boat is rolling from side to side, then of course the shape of my hull isn't going to be symmetric in the water, and therefore a transverse center of buoyancy will exist temporarily. So let's say that my ship is listing in the water, like so. My center of buoyancy will shift to a point, say like right here, and then my center line of my ship is right here. Now, I do have a transverse center of buoyancy until this list condition is corrected. And that's my transverse center of buoyancy distance.